Okay, so hi and welcome. Can you hear me? Hello. Hello. Can you hear me?
Yes, yes, I can hear you. One person only. I don't see any.
Okay, thank you. Just you're waiting 1 or 2 minutes for joining all of those other participants, then we'll start. Okay. So just
Okay, okay, okay.
okay, so let's go over today's session. So basically today is our third number of class. And basically okay, so let's go simply share my screen and show you all of those things one by one. So now can you see my screen? Is it visible?
Yes, I can see.
Okay, thank you. So today I will try to discuss about that how we can easily calculating any indices from satellite images, any kinds of equation or any kinds of raster calculation, how we can easily do using the satellite images. And we also try to discuss about the land surface temperature monitoring, how we can do that, and filtering and displaying the satellite sentinel to satellite imagery. Okay. And previous class I also tried to discuss about the Landsat, and today's class I show you that how we can easily filtering and displaying the satellite images, mainly sentinel to satellite imagery, and using this satellite imagery how we can easily make the NDWI, mainly normalized difference water index. And then we also try to discuss about the NDWI NWI time series chart, and also talk about the how can you explain shuffle, it already done for the previous class, and how to add the gradient legend on your map, how to calculate NDWI from the MODIS and Landsat data. So let's go about the filtering and visualization of satellite images in Google Earth Engine platform. So Landsat and Sentinel, both of satellite images, is the same process for filtering and visualizing, and also exporting is the same process. So first of all, you have to selecting your region of interest where you need this image. Okay. So simply import your shapefile or boundary shapefile where you need this image, and then you can work with that. And then also need to filter the image properties. Suppose you need the image not only more than 1% cloud cover, so you also need to filter this image properties and any specific time period. Okay, rainy season, dry season, or any time period which you need, simply select your time period. So in this time I will show you that all of those things one by one. So let's go. So just I simply open my code editor. So just I simply search here or simply go to the browse data catalog, then I can get all of those data set. I need to work for the sentinel. So click on my data sentinel. So here I can get all of those things in here. You can see. So just click on the multi-spectral instrument, sentinel 2 satellite imagery. So here I can get surface reflectance and stop atmospheric. Okay, both of image is the same process when you filtering or displaying. So I show you in this time our surface reflectance. Click on here. So here I can get all of this information about this surface reflectance, multi-spectral instrument, satellite images. So we can get the availability time period, dataset provider, European Union is Copernicus, and Earth is a snippet. So this is the unique ID of this dataset. As well as we also get all of this information about the dataset, band, image properties, all of those things we can easily get from here. So first of all, I simply copy this artisan snippet and paste in my code editor. So I also increase the code editor. And you can easily get it. So just paste in here. Okay. So this is my image collection. I simply paste and then give a variable name. You can put any variable name. Suppose I put the variable name is that sentinel 2. Okay. So now this image collection I need to filter for my study area. Okay. So first of all, we have to define where you need this image. Okay. Suppose in this time I need the image for the Dhaka city or any specific region. And here I already imported the boundary shapefile of Dhaka city. Suppose I simply click on here, it will be imported. And default variable name is the table. If you want, you can easily change it. So suppose I put the variable name is that ROI. Okay, or you can put any name. So now this image collection I need for the ROI or my Dhaka city region. So just take a variable. Suppose I need this filter in this time. So I put the variable name, suppose image, image, and then I simply call my full image collection sentinel 2. Okay. In this time I need this image for the Dhaka city. Okay. And Dhaka city boundary is stored in ROI file. So just use a function filter bounds function. Okay. So mainly it intersecting the full image collection with my region of interest, Dhaka city. Okay. So in this time I simply put here that ROI. Okay. So mainly this ROI identify my specific boundary of Dhaka city. And then same, suppose put here the filter, suppose filter metadata. In this time I need this image less than 1% cloud cover. Okay. So in this time you have to check about the image properties. So in this time this image property is the different for the Lancer and Sentinel. Image property is the different. So in this time suppose I need the cloud pixel percentage. This for the Sentinel imagery. Put here cloud pixel percentage. I put here suppose less than 1. Okay. After that I simply put the another function, suppose filter date function. Suppose I put the time is the year of 2020, 1st January from year of 2020 March, suppose 30. This time period. Okay. And then take, so in this time I filter. So this is my filter where I need this image. And this filter, I filter for image properties. And this filter for a specific time period. Okay. So now in this time, all of those images, if you want to work for the single image or if you want to work for this single image, just you can simply print that. Suppose simply print, then you can get all of the single image acquisition time period. So this is my image collection. Here I can total 15 images, and all of those images acquisition time we can get from here. All of the single image. So it's a single image. So when you want to work with a single image, just simply copy this ID, okay, and apply the same process which I already show you. So in this time, I just created the median composite using the total all of those total 15 images, and then it clip with my boundary shapefile. Is that ROI? So now display the image. So use here map dot add layer function. and call my object image, click to the run. So now it display the layer, but not focus in my study area. So for focusing, use the same function map.center object. Object is that RY. Double zoom level 10, click to the run. Okay, first time we can get this type of color because in this time it show the default color. So in this time I just set here the visualization. Suppose I set at the red band, green band, and blue band. Custom stress 98% and apply. So now we can get the better visualization of the Sentinel-2 satellite imagery for the Dhaka city. Okay. So after that, simply import. You can see import button. So when I click on the import, a new line of code added in my code editor. Simply copy this variable name and paste after the object name. So this is my object and paste here. So now it's set it. I put the layer name. Suppose I put the layer name is the dry image. Okay. Or you can put any layer name or dry season image. Okay. So now we can get this type of image. You can see. So now you can easily use this satellite image for making the different types of remote sensing analysis. Okay. So in this time, I will show you that how we can easily create the NDWI both two season. Suppose dry season as well as also rainy season. Okay. We can easily find out the different types of water logging in the rainy season. So let's go about that. So in this time, I get the image for the dry season time period, but I need the image also for rainy season. I use the same code, just simply change the time period. Okay, simply copy the same code, just simply change the time period. So I simply put the change the variable name, suppose image, suppose wait, just simply change the variable name and also change the time period. Suppose I put here that June and put here the suppose October. Okay, then all of this will be same. Simply copy and paste. And I also set the letter about that. So click to the run. So now it will be show the wet season images between this time period. It added the another layer. Okay, let me check. Cloud busy version is okay. So Sentinel-2, it's showing that there is the no image. Okay, so for that, first of all, you simply check. Pause. Simply print how many images available between this time period. Simply copy that and paste and use at the size function. Okay. So in this time, it show that this time period there is the zero image. Okay. So in this time, it show the zero image. So when you face this type of problem, suppose you try to find out the get if there is the no image. It means that for in this time period, for this region of interest, less than 1% cloud person image is not available. So for that, you have to increase the number of the cloud pixel percentage. Suppose in this time I simply check the 5, how much image is available for the 5. In this way, get the 2 images. Okay, you can see less than 5% is the 2 images. So now it will be easily work and we can easily get the image. Because in this time period, less than 1% image is not available for my study area. So that's why I simply increase the value and I can get the 2 images. So now I just use this 2 images and make the median composite and now it will be displayed in my map. So let's go. So just use at the map.add layer. Now click to the run. So now it added the another layer. You can see first time we look this type of color. So just simply click on here. And now I set the pen combination red, green, and blue, stretch 98%, and then apply. And also import it and simply copy these things from here and paste after the object name. So this is my object, paste at the visualization, and also put the layer name. Suppose rainy image or rainy season image. In this time we can get this type of color. And we can get the some cloudy, you can see cloud region in here. Okay, but this type of cloud, and also here also increase the visibility of the satellite images using the different types of function. So further class I'll try to discuss about that, how we can easily remove this type of cloud. Okay, so in this time here you can get the two type image. You can see the dry image and rainy image. So basically dry image very clear, we can get that all of those things very clearly. But you can see the rainy season image, we can get this type of things. We can get the some cloud and also get this type of things. So in this time, or just this type of cloud we also remove from here. Okay, so further class I'll show you that how we can remove for that. So now I just try to find out what is the condition about the water on the surface. Okay, for the dry season and wet season. So for that I just use the NDWI. Okay, so in this time we just calculated the NDWI for dry season and wet. Okay, so for that just take a variable. Okay, before that, what is the NDWI? So mainly you can see the equation about the NDWI. Okay, this is the equation about the NDWI: green minus near infrared divided by green plus near infrared. So in this time I just use this water index and then try to find out the NDWI. So now how I can implement this formula? So just take a variable. Suppose I put the variable name is that NDWI. Suppose dry. Okay. So now you need to call the dry season image. Okay. So here you can see this is the dry season image. I simply copy this variable name and paste here. Okay. And use a function normalized difference. Okay, normalized difference between two band, green band and near infrared band. Okay, so you can check the band name from here. Green band is that B3 and near infrared is the B8. Okay, simply put here the green band B3 and near infrared band is the B8. So now it calculated the NDWI for the dry season, and now I want to add the layer. So map.add layer of NDWI dry. Simply copy that and paste and click to run. So we can get the result about the NDWI look like that. Same approach also apply for the wet season. Simply copy the same code and paste here. Just change the image variable name. Okay. Now call the image variable name is the image wet. Okay, or wet season image. Simply copy and paste. So now add the layer about that. So use add the map dot add layer. And also change the variable name. Suppose NDWI for wet. Okay, just change the variable name. Simply copy these things and paste here and click to the run. Okay, so now in this time I just set here the color for the visualization. Just simply try to add. So you add the mean, and you can easily get the mean and max value. You can easily generate from here. Suppose you can simply click on here. Okay, suppose this layer, click on here, and then stress it. Suppose in this time my state is 98%. So then I can easily get the what is the actual value for my study area. Click copy the mean value. And paste here. You can take that to edit, no problem. Okay, and also copy the paste value. Okay, but it shows the both of is a negative. Why? Okay. Let me check. Okay, any question, please? Yeah.
Yes,
Yeah,
for
please.
NDW,
Yeah.
Can you hear me?
Yeah, I can hear you.
For NDW, we know that there is a formula like
Yeah,
subtract or divide or add. We know that.
yeah. Okay,
So
so yeah. Okay,
instead
understand
of
your
it,
question.
we used normalized difference.
Yeah. So further,
So
I also show you that all of this process one by one. So in this time, it's the one way to calculate it the in normalized difference. Okay, so this type of index we are calculating the different way. Suppose we are just put here this type of suppose green minus near. We can also put the formula expression. We can easily put, but normalized difference we are also put, and mainly normalized difference is function. It able to calculate any two band. Okay, any two band if normalized difference it calculate, and you can see here simply copy this and then paste here, and it computed. You can see mainly this function computed the first minus second divided by first plus second. Okay, it computed as the first plus second, first minus second divided by first plus second. Suppose in this time I mentioned here the first band is the B3 and second band is the B8. So now it automatically calculated first B3 minus second B8 divided by B3 plus B8. So this function, it's built-in function, it automatically calculated any two bands. Okay, only for the use for the two bands, but different types of index you can also see. Suppose EVI or SAVI, this type of things we have to add, need to more different types of constant value. Suppose you can see this is the formula about that EVI. EVI formula, you can see there is a 2.5, B8, B4, also B8, okay, B2. You can see this type of formula or this type of index we calculate using this difference function. Okay, normalized difference function is not work for this type of equation. So then we have also need to put the other way to calculate this type of things. Okay, but when you want to calculate any two number, any two bands, suppose NDVI or NWI, or only for the two bands, any index, we are just apply here the normalized difference function and mention here the first band and then second band. Then it automatically calculated first minus second divided by first plus second. Okay, and how we can easily calculate this type of index I will show you in this class after some time. Okay, okay, so any question?
uh, uh, furthermore, for in map add layer,
Yeah, yeah,
you have used the range like minimum and maximum.
yeah, yeah. Okay,
So can you describe it for me?
okay. In this time, okay, I add again. Suppose in this time I just put here the curly bracket and put here the mean. Suppose I put here the -1. Basically, all of those index, suppose NDVI, EVI, or any difference index, normalized difference index, this range all time, this range -1 to +1 all time. But this value will be changed for a specific region. Suppose all time we did not get the -1 or +1, it will be reduced. Suppose this my study area, -1 mainly for the NDVI, for the NDWI. What happened? NDWI, when increase the high positive value identify the water pixel in the NDWI. High positive value identify about the water pixel. Okay, and negative value, it's not a water for NDWI, but for NDVI it's totally opposite. For NDVI, negative pixel value identify the water pixel, and high positive value identify about the vegetation. Opposite. For NDVI and NWI, this thing is the opposite. And this pixel, suppose this I can get the two types of map. In this time, suppose when you want to just work, suppose I show you some example from my previous work. Suppose here you can see this one kind of, suppose this is the map, you can see. This is the map. I just download the tip image from the Google Earth Engine platform. Okay. And when I import this map in ArcMap software, it automatically show me what is the high value and what is the low value of this NWI map for my Dhaka city. So in this time, this value we from this map we did not understand about this value. What is the actual minimum and maximum value for this map? We don't know, but we can also calculate the value about the maximum value and minimum value. We can also calculate. Okay, so that's why in this time for the visualization we simply set a default value. Okay, set as a default value and visualize. But when you export this tip image of NDWI and import in ArcMap software, then it automatically display the high value and low value of this NDWI or any other index. It automatically show the high and low value from it. From that you can easily get the high and low value, and from the symbology you can easily take the color. Okay, you can easily take the color. So as you can see the high value 0.5. Okay, so this type of pixel will identify about the 0.5 at the positive value, and positive value identify about the water body. Okay, and negative value it's not a water body. Okay, negative value it can be built up area or vegetation or barren land, but not water. Also you can see the nitrogen dioxide density map. So mainly when you want to export this map and import in the ArcMap software, it automatically showing what is the high value and what is the low value. From where you can easily get this. Suppose you can see NDVI map. This range will be -1 to +1 all time, but not a specific one, -1 and +1. Okay, but it will be, you can see it show the low value is the -0.1 and high is the 0.7. Okay, this range will be -1 to +1, you can see, but not -1 and not +1. So that's why in this time we are just simply, suppose I show the result mean and max. Suppose put here the 0.5. Okay, and put here the color plated. And from the ArcMap software, we are just using the symbology to add this type of color. And how we can easily do that? So further class, I also show you that for that how we can easily create the map using the ArcMap software after downloading the tip images. So I simply set the color, suppose red. Then suppose use at the yellow. Suppose push at the green color. And for the water body, I show as a suppose blue color. And also suit at this map for the suppose NDWI for suppose dry. Okay, so now you just implement the same things also in my second layer of map. Simply copy the same things and paste here. Paste here. And also change the layer name. Suppose put the layer name with the NDWI. Wait. So now click to the run. So in this time it set the visualization. Okay, but this visualization is only available in Google Earth Engine. When you want to export this map, you did not get this type of visualization. You can get the grayscale color. Grayscale color. Okay. In ArcMap software, we can easily use the different types of visualization. Okay, then we can easily do that. So in this time here you can see this is the map we can get. In this time we can get the water body as a blue color. You can see. We can get the water body as a blue color. And here you can see the result. This is the dry season. Sorry, this is the dry season. You can see it is a dry season. So I zoom it. This map for the dry season. Okay, in Dhaka city. And also you can see this is the map for rainy season. And you can see here we can get this type of water body pixel value increased in the rainy season for rainfall. Okay, and you can see. So now from here, if you want, you can also make the change detection map of NDWI and how much water body increase in the rainy season. So these type of things we can easily calculate in Google Earth Engine platform also. So in this time here you can see we can get the two map look like that, rainy season and dry season. This is the dry season. Okay? And it's for rainy season. If you want, you can also export this type of map as a TIFF format and make the map using the ArcMap software. So this process I show you the further class, inshallah. So now let's go. So in this time, I just need to calculate it. How much water body increased, okay, in the rainy season. I want to calculate. And if you want, you can also check about that, suppose pixel value, suppose in Inspector tab and click any map. Suppose I just click on here. So now we can get the pixel value for the dry season and wet season. You can see. For the, you can see, in the dry season, I can get the 0.05. Okay, 0.05, and for the rainy season I can get the 0.5. Okay, so this value is increased in the rainy season, 0.5. Suppose I check the another region, you can see in the dry season there is no water. Okay, for this coordinate or geolocation, there is no water in the dry season. I can get the negative pixel value. Negative pixel value means that there is no water. But when I can get this rainy season, I can get the 0.5. Okay, I can get the water body in the rainy season. But dry season, there is no water. Okay, so also you can see, suppose I click on here. Also you can see for this coordinate, what happened, you can see there is no water in the dry season, but rainy season I can get the water. So now from here, I just need to calculate it. How much area will be increasing the water body. Okay, so for that, so let's go. Okay, so in this time, I just calculated the area, how much water body will be increasing. Okay, so for that, just take a variable. Suppose I put the variable name is that, suppose wet season, suppose water. Okay, you can put any variable name. And now, first of all, in this time, I just set the condition. So using thresholding, suppose in this time I just simply click on here and you can check the value. we can get the NDWI dry season 0.08. Okay, also we check the other value. So in this time we have put the thresholding. Okay, so thresholding mainly it's not a fixed or constant. It will be vary from region to region. So that's why in this time, suppose in this time, I just simply call the NDWI dry, and all of those greater than 0.2. Okay, all of those greater than 0.2, and NDWI wait. Sorry, it's the NDWI. Okay, NDWI weight greater than 0.2. Sorry, it is the NDWI weight greater than 0.2. So all of those pixel value NDWI weight map greater than 0.2 and NWI dry less than suppose 0.2. Okay, so NWI greater than all of those pixel value greater than 0.2 I consider as a rainy season water or rainy season water area, and NWI dry less than equal less than 0.2 pixel value. So using this condition, suppose NWI weight greater than 0.2 and NWI dry less than 0.2. Using this condition, I just calculated the all of those area. Okay, all of those pixel value using this condition. So now I just show you that. Suppose just take a variable. Suppose water max, and then simply call the wet season water. These things. In this time, just using this condition, all of those pixel value display on the map. Okay. So using this condition, all of those pixel value I want to display on the map. So for that, I simply use a function update max function, and I want to update max using this condition. Simply copy this my condition variable name and paste here, as well as just simply use a self max function for just use at the self max. Because I show the later about that. Show your layer first. Suppose map dot add layer. Yeah, please. Any question, please? Yeah, any question? Okay, just in this time show the water body map using this condition in the wet season water.
Sir, how you have displayed the chart in
Don't
spreadsheet?
understand? Yeah, please. Okay, display the chart. Okay, let me one by
How
one.
you have displayed the chart?
Yeah, I will show you that. Okay, just a 1 minute. After that, we discuss about that topic. No problem. Okay. So in this time, I'll also show you the chart how you will create the time series chart also about that things. Okay. In this time here you can see I just create the watermarks. Okay, so you can see it create the another layer. Because I also add the color. It also better for that. Suppose I add the color. Suppose I add the plated suppose blue color. Okay, and they put here the suppose layer name suppose rainy season water. Click to the run. What happened? Oh, you have set the second bracket. So now it will work. You can see. We can get the rainy season water layer, and it show only for the rainy season water map. You can see this type of water we can get the rainy season. Okay, so now from here we can just calculate it the area. Okay, how much area I can get from here? We just calculate this type of water area. And what is the condition about this area? This pixel condition is that greater than 0.2 and less than 0.2 from dry and rainy season water map pixel value. Okay, this condition. So using this condition, we can get this type of water pixel value in here. So now if you want, you can also just extract from here as a water body map of rainy season only. So now I show you that how we can easily calculate this pixel area. Okay. So for calculating the pixel area, Suppose I just take a variable, suppose area water. You can put any variable name, and then just call this watermarks, because this variable is only available for the water area in the rainy season. I simply call and paste here, and use a function. This function called the multiply with my function ee dot image dot pixel area, this function. Okay, and now I just calculated the area using the reduced region function. Just take a variable, suppose or if you want, you also can add in here, no problem. Suppose you can use the only for the one variable, you just add here the other function, reduce region. You can put all of those things one by one. Suppose just make the dictionary, curly bracket start, and also curly bracket end, and then put a reducer. So reducer basically statistical function. In this time I calculated the total area. Okay, so just put here the ee dot reducer dot sum. Okay, total area, and geometry is my boundary. My boundary is that ry, shapefile variable name. Scale is the resolution 10 meter. CRS not yet, remove that. It's not need. So remove that. Simply copy that, and then simply print that. So print that area water. Simply copy that and click the run. Okay, in the console we can get the result. You can see. Okay, we can get this type of result, and this result is a square meter. Okay, so in this time we can simply convert into a square kilometer. So for that we can simply take the another variable. I put the variable name, suppose area. The area I simply put here that it's a number. You can see it's a number. Okay, so that's why you have to use a function ee dot number. Okay, and this number is stored in a variable. What is the variable name? This variable I simply copy and paste. Okay, and now I am to convert, and you can see this number mainly get from the nd. Okay, just I put a function dot get nd. So put here the nd, and then finally suppose in this time, suppose I need the suppose hectare. For the hectare, just simply multiply. Suppose multiply 1 into 10 inverse 4, or scientific notation 1 e inverse 4. Okay, now we can get the result in hectare. So simply print the area. Take to the run. So now it show the result in hectare. How much water we can get? Okay, 1,473 hectare. Yeah, please. Any question?
Hi.
Yeah,
Yeah.
please.
So you use the reducer function here.
Yeah.
Is it for like you first calculated all of the area for all of the pixels and then finally summed up all of these pixels?
Yes. So
Okay. And another question is if you can go a little up, like scrolling up further up. Yeah. Yeah. So how do we get to know that? How do we
okay,
set
so
the
for
values
that,
for
okay, for
greater
setting
than
this
and less than?
thresholding, we have to
Yeah.
just check some pixel value from here. Suppose in a separator tab, we have to some randomly check some value. What is the condition for the, suppose in this time here you can see this is the lake of Hatirjir Lake. So in this time it's a permanent water body. We have to set the permanent water body, what is the threshold value, as well as what is the suppose rainy season water value, what is the value about that. Suppose in this time, suppose click on here, suppose you can see, and this water board we can get the both of time. You can see, suppose you can see, yeah. So yeah. Suppose this thing, suppose click on here. For that we can get, what's the value? We can get the 0.1. Okay, for that dry season 0.1, and we can get the wet season for this 0.3.
Yeah.
Okay, so now from here, NDWI wet season, when I consider the all of those pixel value greater than 0.2 and also less than from the dry season 0.2, then we can get the rainy season water. Because here I can get the NDWI dry season, for the permanent water body is the 0.1. Okay, so in this time I not consider the permanent water body, so that's why I simply increase that. So wet
Okay.
season, suppose in this time in the wet season we can get the 0.3, we can also get the 0.2 for the rainy season also. So that's why from the rainy season we can get all of those greater than 0.2 pixel value, all of those from 0.2, all of those greater than pixel value. So from that you can just simply check some random point of the value, and from here you can set the thresholding and then calculate it that. And it also used for the flood mapping, for the flood mapping water thresholding technique. We are just use this type of check about the what is the value for the pre and what is the value for the post. Okay, then we can
Okay.
set the thresholding value and identify about the water pixel, how much increasing or decreasing.
Yeah. Thank you.
Okay, so now we can get the result from here, this step. Okay, so now suppose I want to make the time series chart. Suppose what is the condition about the time series chart. Okay, so this type of time series chart, previous class I already show you, so in this time I'll show you again. Suppose time series chart. So in this time I calculate the time series chart. For that we have to need the band. Okay, for the time series chart we need the band. So in this time, this image collection, there is no band. So that's why first step you need to just create the band. Okay, so first step need to create the band. Create a band. So in this time I need to create the band of NDWI, because I need to make the time series set for NDWI.